we have discussed in previous class that example number 18. Do you have any problem in example number 18?
No, but could we go through it once again?
Okay, so first of all, here we have the example 18. Find the stationary points on the curve f of x is equals to 2x cube minus 15x square plus 24x plus 6. This is our given function, that is cuboid function, right? Because here the cubic uh, power is seen in this function, and state whether they are minimum or maximum points. So we have to find the minimum or maximum points. So for minimum points or maximum points, first of all we have to find the gradient function, and gradient function will be f prime of x, that is 6x square minus 30x plus 24. Do you understand or not?
Yes.
Okay, after finding the derivative, we just equate this gradient functions equals to 0. It will become 6x square minus 30x plus 24 is equals to 0. So in these three terms, you can see that 6 can be taken as common. So 6 into x square minus 5x plus 4 is equals to 0. So this x square minus 5x plus 4, this is a quadratic equation. We can solve it by using the factorization method, and its factors are x minus 4. This square is not included. This is the printing mistake. X minus 4 and x minus 1. So it will become 6 times x minus 4, x minus 1 is equals to 0. Do you have any problem?
No.
Okay. So from this expression, from this equation, we have two values of x. X is equals to 1 and x is equals to 4. Now these are the x coordinates. When we put first x coordinate, that is x is equals to 1, into your parent equation, so you can see that it will becomes 2 times 1 cube, then minus 15 times 1 square, then 24 times 1, then 6 as it is. When we solve it, when we simplify it, your answer of f of x is basically equals to y. So your answer of y is 17. So this point is generated by substituting the value of x is equals to 1. Again, we have another value of x, that is 4. So when we substitute the value of 4 into the same equation, then we obtain another point, and other value of y, that is minus 10. So the point will be 4 and minus 10. Do you have any problem till these points?
No.
Good. So after that, we have the derivative, that is 6x square minus 30x plus 24. And if we take the double derivative, what is the answer? The double derivative will be 12x minus 30 plus 0. So we can write it as 12x minus 30, right? This is the double derivative. Now you can see that if we put x is equals to 1 into double derivative, then your answer will be minus 18. If you put x is equals to 4 into the double derivative, then your answer will be 18. And in previous class, we have discussed that if the double derivative is less than 0, derivative is equals to 0, that's okay, we have done. Derivative is equals to 0, we have done in this example. But if the the double derivative is less than 0, it means that double derivative is negative, then your point is maximum. If double derivative is positive, the point is minimum. So in this case, you can see that when we put x is equals to 1, it means that we are using that point. For that point, the double derivative has the value negative. It means that at that point we have a maximum point. Again, you can see for this point, because we are substituting the value of x is equals to 4, so we use that point. In that point, when we put x is equals to 4 in double derivative, you can see that your answer is positive, greater than 0. It means that at that point 4 minus 10 is a minimum point. Do you have any problem in this example?
No.
Okay, good. Next is this is an extension activity and will not be in this exam. So this is the extra extension activity. So we have to study this activity. Consider the curve f of x is equals to 6x minus x square below. So we have the function that is 6x minus x square, and we have already seen that this is a quadratic function, and if a quadratic function has negative coefficient of x square, then we have the parabola, but the parabola in opposite direction, at that direction. Just wait a minute. At that direction, right? So this is the graph given of this function. The gradient of the tangent at any point is given by f prime of x, that is 6 minus 2x. So if we take the derivative of that quadratic function, your answer will be 6 minus 2x. Do you have any problem in till this step?
No.
Okay. So at the point f prime of 1, the gradient is 4. So if we put 1 into this gradient function, then your answer will be 4. When the gradient has a positive, when the tangent has a positive gradient, the graph is going up and the function is increasing. Now we are discussing about the function is increasing or decreasing. So we can see that our gradient is positive, and when the tangent has a positive gradient, the graph is going up and the function is increasing. Again, if we put f prime of 4, right? So you can see that the gradient is minus 2. When the tangent has a negative gradient, the graph is going down, the curve and the function is decreasing. It means that if the first derivative, when we put the values of x into the first derivative, your first derivative is positive, the function is increasing. If the first derivative is negative, the function is decreasing. Again, if we take the double derivative and the double derivative is negative, it means that it is the maximum point. If the double derivative is positive, it means that it is the minimum point. Do you understand? From first
Yes.
derivative, we get the information about the function is increasing or decreasing. From the second derivative, we get the information that the point is maximum or minimum. Okay, at the point f prime of 3, the gradient is 0 and it is called the stationary point. Stationary point means that here the graph is not increasing, the function is not increasing nor decreasing, right? So the key points are that if f prime of x naught means that a specific value, let this can be 1, this can be 4, this can be 3. If f prime of x naught is greater than 0, it means that it is positive, then the function is increasing at x is equals to that point, right? If f prime of x naught is negative, it means that function is decreasing at that point. If f prime of x naught is 0, it means that f is stationary at x is equals to x naught. This is the key point. Do you understand this key point?
Yes.
And you can see that what is the value of x is equals to 1 is like this one. It means that at that point the graph is increasing. At 4 is this one, so you can see that at that point the graph is decreasing, right? And at 3 is at that point, sorry, at that point you can see that the graph is not increasing not decreasing. So this is called the stationary point, and stationary point has not a decreasing value or increasing value. Any problem? And you can also see that the stationary point can be obtained when we put first derivative is equals to 0.